Okay. So it says, graph the following functions. Be sure to identify all 5 transformations, plot at least one period. This will be done with the 5 important points and identify the domain and range. Let me see.
These are the. This isn't the quiz. This is the.
No, the quiz is down
Questions.
here. That's the quiz.
Okay, where it says quiz.
Yeah, this is not the quiz.
Did Sister Hass give you any specific instructions for today?
Just this. Not that I remember. I could check.
No, you're good.
Well, we'll check. Team discussion. Discuss and make sure each team member understands the 5 different transformations and 5 important points used for transforming the sine and cosine functions. Discuss the 4 additional trigonometric functions. Be sure that each team member can tell the relationship between the 4 new ones in the sine and cosine functions. Review the answers to question number 6 from the preparation and ensure that each team member has the correct answer. If any other answer is incorrect, spend some time discussing the correct answer and how you found it. So I think this is going to cover most of that. So
I agree.
That first one, I just looked at practice problems. It's 1/2 sine instead of 12 sine. I don't know if that'll make a difference.
It
that
would
actually will make a difference.
make a huge difference.
No, 1/2 sine instead of 12 sine. Does that make sense?
Oh, that was just 2.
So it's 2x and then 1/2 sine. Yeah.
Whoops. Yeah, that'll make a difference.
Nice. Well, alrighty.
Two x minus pi whole thing minus 1. Alrighty then.
So just by looking at what we have, right? We go. So it's probably shrunk by 1/2.
Mm-hmm.
Down 1. And there's no reflection, right?
No, because it's not negative at the beginning.
Yeah.
1, and we also know that it moves to the right
Anymore.
What?
Your screen sharing turned off.
Oh, darn it! Of course it did.
I could be proactive and pull up the problems on my own computer, but it's so much more convenient if it's on yours.
Oh my.
Does that look better? Yeah, there we go.
Yes.
And then we know that it moves to the left pi spaces.
I thought inside the
Oh, right.
parentheses. Yeah.
Right pi, you're right.
Do we have to do anything to this equation at all in order to find any transformations?
I mean,
think
it's
so.
already a sine.
True. I was just wondering.
Okay. So I just did you need to know what was the keyboard shortcut for pi? Yeah.
What is the keyboard for pi?
I don't know. Do you have a Mac or a PC?
I've got a Lenovo, a PC.
Can't help you with that.
Come
What is it?
on.
It's option P.
Option P. That's so simple and awesome.
It's like it's clearly, yeah. It's pretty.
Hey, you should, Jason. You should try Option P. See what happens.
Do they even have an
I've
option?
got function P.
Yeah, try it.
No, but that's command for us. That's not option.
My function wouldn't do anything. That would be more of a control type thing for me.
Yeah, do it. Try Control P.
That's print.
Yeah,
Definitely print.
definitely.
Well, what do you say?
Who needs the I symbol anyway? You don't use it for anything except for this class.
Okay, and then there's something with this 2x. Would it be doubled? Would x be just doubled?
Yeah. So, but I don't know. Like the sign. Let me just look at like what a sign graph would look like. I'm not gonna look up the one that we're doing. Don't worry, guys. I'm just gonna like type in a random one.
It's just a wave. I know what it looks like normally, but do that real quick. Let me think. Try to do this right. Oh yeah.
So one of them controls the frequency, and the other one controls the length.
So that's like a basic sine graph right there.
It's beautiful.
I know, but the question is, what do we have? So it's got to be half as high as that. Maybe it's more wider, 2 times more wide. That could be.
I'm not sure.
I don't know. Do you guys remember what the 5 transformations are supposed to be? Don't remember off the top of my head.
So you have the shrink, you have the reflect, you have the right, you have the down. You know, right or left and then down.
Yeah, and then I know you've got.
So one that you're missing is not reflected over x-axis.
No reflection. Okay.
So you've got left, you've got down, you've got to the right, no reflection, and that 2 is the other one.
Yeah. So is it just stretched out by 2? Because it's x. Yeah, that makes sense. It'd be stretched out by 2 because it's x. So we have to stretch horizontally out by 2. Does that make sense?
Yeah.
So we want to cut that down by half. And we want to stretch that out by 2. And pi. Okay. And then, so the domain. What would the domain be for this? So you just, whoops, I forgot one thing. Down by 1. There we go.
The domain for this just be all real numbers.
Honestly, yeah.
That goes all the way across.
Yeah. Guess I should have denoted that. Oh, shoot. Stop. Sorry, it's going to stop screen sharing. But it's because I have to add some arrows to the ends so that it's correct.
That's okay, man. I forgive you.
Oh, not that.
But I'm like the most sarcastic person ever, so.
Oh boy. There we go. There we go. Okay. And then the question is, what is y? Y is supposed to be between two numbers. It only goes the height of the curve and then to the bottom of the. Y only goes from here to here. The question is, what are those numbers supposed to be? Well, we know they're going to be negative because it's below this. But I would guess, no, could it be 1 and 1, 1 and -2? Maybe not, though.
What are you looking for? Just the range?
The range. Yeah, it's the height and the top of this and the bottom of this. What value of y is that? That will get you this, the range, because the y only goes between the top and the bottom. So I was thinking it said it was down by 1. Oh, maybe not. I think it says it was down by 1, that this would be 1, -1, and that would be -2, but maybe that's not the case. Actually, it says it's half.
So, yes, it's halved. I guess the wavelength is only going to be
half of what it normally is, yeah.
pi, because sine and cosine have an entire completed wavelength of pi, and so it's half, and it's going to be half pi, and it's oh cheese and crow, what is it? I'm like
cheese and crow.
Yeah, it's a New England saying.
Oh, that sounds fun.
It is. It's just got a range of -1 to 1, but
say normally that'd be the case. Normally it'd be -1 to 1.
Yeah, and so, but if it goes down at all, and what do we say, down by 1? So it should go 0 to -2, I think.
0 to -2.
I hope so.
We could check it on a graphing calculator. That'd be the smartest thing to do, I think, at this point, to make sure we're.
I can do that.
Okay.
What is the problem? 1 divided by 9
this
to a minus. That's funky.
So the range on this one is just kind of like the high point and a low point?
Yeah, that's all it is.
Can we just plug in some numbers for X and then plot them out, like map them out, see what they come out to be?
Okay, so I got it right here.
What is it?
Negative 1.5 to negative 0.5. So negative 1.5 to negative half.
How'd you get that?
I graphed it.
Okay.
We should probably know how to do it.
Yeah, I completely agree.
How do we know how to get that?
I'm like looking on like different websites right now to try to find. I could like we could watch Sal do it, but
I don't even know if we can trust Sal.
freaking Sal. Okay. That's kind of making sense. Let's see. Okay, so where is the video? Okay. So I don't know how to do this. No, I meant like explain it in a way that
I know. It just sounded funny to me.
so the middle of the point where the cosine is gonna be doing its wave thing,
Well, sine, yeah.
that is -1. And then the 1/2 in the beginning of it, that decides how big the wavelengths are, like the amplitude of it. So since it's at -1, because we had to go down 1, that means that normally it would be -2 to 0, but because it's halved, it's -1/2 to half, or -1/2 to -1/2. Does that make sense?
So what's like the general starting terms?
The starting term is just sine x, and that would be from a period from 0 to pi. It goes 1 on above the axis and 1 below the x-axis.
So that's like a general. This is like a general range.
That's the general graph. And then since we went down 1, before we did anything with the 1/2, when we went down 1, it goes from -2 to 2, or -2 to 0, keeping that same ratio.
Uh-huh.
And then since we halved it, the graph is shrunk in half. So in the time of going from 0 to pi, instead of going from -2 to 0, it would only go from -1/2 to -1/2.
Mm-hmm.
Does that make sense?
Sort of. Let me see.
Like draw a line in the middle of the graph, like horizontally at -1. Y equals -1.
Okay.
Okay, so that's y equals -1. Normally, if that 1/2 in front of the sign wasn't there, it would be from 0, or it would go from -2 to 0, back to -2 and 0, and just do that for infinite amount of time. Because
now I get it. Yeah.
that's two spaces on the y-axis.
Mm-hmm.
And so since we have that, because that 1/2 is there, instead of 2, it only goes 1. So it would go from -1/2 to -1 1/2 to -1/2.
That makes sense. Now that horizontal line really helps to have it make sense. Excuse me. Should we tackle the next one?
Yes, I don't know how to. I have no idea how to do cosine, so I'm gonna just do a 2-second brush up on that real quick. Okay, you guys can start without me.
Well, I'm sure the same transformations are the same. I think the only thing that'll probably change is going to be the range, if I had to guess anything.
Probably. No, that's not right. Yes, that's right. That's right. Yeah, that's right.
What is the difference between a cosine graph and a sine graph?
Where they start. So a sine graph starts right at the origin, and a cosine starts at 1 and then goes down to 0, and
Okay.
then back up to 1.
Okay.
Or the sine starts at 1, then Anyway, so it is
Up 5.
Reflected in the x-axis, right?
Yeah.
Negative.
and then
Stretched by 4?
yeah.
Stretched by 4, reflected, and it goes to the left pi.
And then stretch out by 3 then? Yeah.
Should we use a separate word for stretched, because we already used that for...
Expanded by 3? No.
No, I almost want to say the amplitude is stretched by 3.
Yeah, that works. We'll go with that. Works. Okay. So stretched out by 4, up 5, and then here's a flip. Left pi spaces. Oh, we can still do that, yeah. That's fine. And function. happy about the graph? Let me check. First of all. Make that red. And there we go. Just check to make sure if that's even feasible.
Close.
Looks like we may have gone the wrong way. Because show me on the graph,
No, I see what you're saying.
it's more like that.
Oh, it's showing me on the graph that it starts. Did I type something wrong? Hold on. It's -4 cosine.
Oh. It should be like that.
Yeah, like that.
That, there we go. There we go. There we go. Okay, now for the range. The nasty part.
Yuck.
They're going to both be positive this time. We know that for sure.
Yeah. So it's normally a space of 2, but it's multiplied by 4. So I'm guessing it'd be a difference of 8. And if the line goes through y equals 5, so that's 4 above and 4 below. So I'm guessing it'd be in between 1 and 9. But let me check.
Yeah, let me check that too.
Well, I got the 9 right, and I got the 1 right.
Yeah, you're good. You got it. Ingenious.
Pulled it out of my butt.
Every calculator. You said pull it out of your butt, so I said the butt of your calculator, maybe.
No, I used my brain first, and then I pulled it out of my butt.
Of your calculator.
Sure, we'll do that.
Okay, so I think we're good there. Number 2. The transformational form of the 4 additional functions is the same as before. The difference is that the tangent and cotangent functions have a period of pi and not 2 pi. Like the other functions, the 4 additional functions also have asymptotes. Plot the parent function for each function. Tangent, cotangent, secant, and cosecant. Wah, wah, wah.
I didn't even understand asymptotes last time, so I'm assuming this is probably going to be really fun.
Well, there's never going to be a vertical asymptote, right?
Yes. Tangent definitely has vertical asymptotes.
Okay, tangents do, but...
Yeah, cotangents do too because they're the opposite. They're just flipped.
Right, that's what I meant. No, I'm just kidding. I have no idea. I was still thinking of cosine and sine.
No, these are the opposite. These are tangent, cotangent, secant, and cosecant.
Well, why do we need to do these?
Because math stands for mental abuse to humans.
I'm like bitter towards these. And for some reason, I'm smelling a candle that I haven't smelled in 6 months.
Is it a phantom smell or is it actually there?
No, it's I lit it and it's keeping me company.
Okay, so it's not a phantom smell.
It's actually a candle.
Okay, so I'll make these all different colors.
My wife had to go to work early, so I'm like, hey, I've got a little bit of freedom in the house now. So I lit a candle.
Does she not like candles? Usually it's the wife that enjoys candles.
Hey,
I'm just saying. I'm just saying.
our
My
candles.
wife's got more senses in candles than I could ever imagine. So
Oh, hey, my sister works for Scentsy.
Really?
Yep.
We have several wax warmers. We're both pretty big on scented scents, whether they come from candles or
wax.
wax. We don't discriminate.
No discrimination. No waxism.
No waxes in here. All right, what are we doing? I don't know.
I'll show you in a second.
Okay, I'll let you do that. I'm gonna check my email real quick.
Oops. Not the lollipop of death.
The lollipop of death.
Oh, that's what I call. You know how Max had that little swirly rainbowy thing? That thing?
Oh, the beach ball.
Yeah, I call it the lollipop of death because it makes me wait.
I think of it as the beach ball of hell.
The rainbowy beach ball.
Uh,
Okay. Okay. Okie dokie okie dokie. So tangent goes like this, and then this. That's a tangent. But after the lollipop of death starts spinning, and I'll change that to not black but red. So we know that that's what that, and put arrows on it. The lollipop of death. There we go. Okay. And then, so we have this as the graph of tangent.
and that's the graph.
Uh-huh. And it repeats itself like that. And like that. And there's a vertical asymptote between each of these. So this is a parent tangent graph. And so that's like roughly what it's supposed to be. There. Asymptote there. And asymptote there. So that, my friends, is a completed parent tangent graph. You can all verify with your graphing calculators if you like.
I trust you.
I'm just going to do so. Just
And I just want to
yeah.
know what cotangent looks like.
Cotangent, if I'm not mistaken, is just this, but the opposite. I'm going to do.
Wowzers.
And we're going to change these to orange so we all know.
Or yellow.
Or all supposed to be orange, but you know, all the same. Oh, what did it do? What the? I'll just look these ones in the end because I don't know where they came from. So again, there's asymptotes right there. And then asymptote right there. Oh, that's where they came from. Gotcha. Yeah. Just the opposite. I can't remember exactly what a secant is. It's got to be something similar anyway. Right, that's right. Same kind of D. Oh, no, just kidding. Okay, that's a little bit more tricky, but it's still simple enough once you get it, understand it. Wow, this is like LSD looking at this graph. All these rainbowy colors.
I would not know.
Want to do that to make it green. So, on this one, you skip every other asymptote spot space, and then you do this. So you take one more and you
Flip them over.
Yeah, you flip them over, and you fill the opposite spaces with those.
It looks like we're like trying to visually create DNA strands.
Chromosomes. This is like a microbiology diagram, honestly.
Yeah, that's what I was thinking.
There. Okay, so the way to know that this is the secant is that the difference between this one and this one, I should say, rather, is where it starts. The secant graph always goes over the y-axis. And the cosecant, if I'm not mistaken, does the opposite, kind of like the other one. Whoops. And yeah, just like I thought. Maybe not. Oh, no, I was wrong. Okay. But it's still simple anyway. Take that and make it. Make that blue. Oh, this kind of does its own thing. It rides the y-axis instead of crossing it.
It does what now?
It's also going over the y-axis like this. It rides it like this and crosses over the asymptotes of the other one. Like that. Goes over the asymptotes. Like a rebel.
Does what it wants.
Ugh. Yeah, that's what I want. Does it make sense to all you guys?
Yeah.
All the mumbo jumbo.
All
Looks
that.
beautiful as well. Makes sense, and it's pretty.
Graph of my dreams.
This is why I took pre-cal right here. This graph.
Um,
Are you not entertained?
identify the domain and the range of all 6 parent functions.
No.
Just now. We have sine, we have cosine, we have tangent.
Domain and range. The domain for all of these, wouldn't it just be? I don't know.
Okay.
I was gonna say, wouldn't it just be all real numbers for all the domains?
I don't think for cosecant and secant.
Huh.
Okay, let me do this a little bit simpler. I mean, that's what we look like, but I think it'd be better if we all... Oh yeah, we can start with this one. So we know that sine has a domain of all real numbers. So does cosine. And so does tangent and cotangent. Yes, yes. And range for this one is between -1 and 1, or no? Yes. Between -1 and 1. And I believe this one is also the same, -1 and 1. Wait. That's not right. I don't think this is correct. I think this is the range. Let me pull out something. Then you can see what I'm talking about. Um, so that's what that's supposed to look like. That's a graph of a tangent function. Just repeating and repeating and repeating. So all the y values is true. It will hit, and all the x values, I don't know what you would put for the domain.
I gotta use the bathroom real quick, guys. I'll be right back.
Sweet, go ahead. Yeah, I don't know what you put for the range for that, or the domain, excuse me.
Domain.
Because every other one, it just skips.
Would the range be all real numbers then?
Yeah, the range is what I'm saying. It's the range is all real numbers.
Holy cow! Yeah, like a sun behind me. Oh, ho, ho. Let me move real quick.
Well, there's only one way to find out. Just kidding.
Me, I don't know. All look like all real numbers to me, but I'm not sure. Except for maybe the range is the one where.
I think the range is supposed to be all real numbers. I'm not sure. I don't think that's the domain.
Says the domain of the function tangent is all real numbers except the values where cosine x is equal to 0.
So just both, I guess.
For all integers n, the range of the tangent function is all real numbers.
Sounds good to
So
me.
it's all real numbers except for where cosine x equals 0.
Sounds good to me. And then we can switch that to secant.
You doing secant or cosecant?
Secant first. Let's go zoom in on that.
So for secant, it says the range of the function is y is less than or equal to -1 and y is greater than or equal to 1, is what this thing is saying. And then it says the domain is all real numbers except where cosine is equal to 0. So
I think it depends on who you ask.
well, even in this one, you can see it on their graphs. It all stops at 1 and -1 for their range.
Oh, that's true. It'll be -1, 1.
Yeah. Well, I think it'd be y comma negative, or infinite. What is it? X. Y. It would be infinite -1, and then the u sign where it includes, and then I do 1 infinite. Right? Because they're two separate things, so you can't include both of them in one of them. So you have to use that u sign to say this one or this one.
I think, yeah, you're right. It goes between -infinity to -1.
And then it goes from 1 to -infinity, or infinity, I mean.
-infinity, -1, and -1 to infinity. Yeah.
So you'd have to do that little u sign in between them.
Yeah, I got it. It's there.
Yeah.
It's there. You just can't see it.
No, it's fine. I was just talking myself through it.
And then I'll go for the cosecant. Okay. So this is explaining to you why the cosecant is related to the sine graph. Because it's upside down and right side up parabolas are following the pits and tops of a regular sine graph. So that's showing you why it is the way it is. Anyway, so I think it's the same thing, exact same thing as before, but that's a little better explanation. Period. Okay. Let me change it back so I'm screen sharing the document. There we go. Okay. Identify the period of all 6 parent functions. P for period, P for period, P for period, P for period, P for period. So period is the width. Oh, I know what it's talking about. Is that tangent and cotangent functions have a period of pi and not 2 pi. So she just gave us that tangent and cotangent have a period of pi. And then all these ones have a period of pi. Do the same thing, try to print it. Two pi, I mean. Tangent and cotangent have a period of pi. These ones are 2 pi as well. Oh, easy. There we go. Well, that was easy. Let's go to the quiz now.
I'm glad we have different opinions on easy.
Well, it helps that I've done this before. You know what I mean?
That is a little bit of an advantage.
List the transformations made to the cosine function and write an equation of the form a cosine b times x minus c plus d, whose graph is the given function. Also state the range, domain and range, I should say. Excuse me. So y equals something times something times x minus something. Yes. Plus something.
So just write cosine in there somewhere.
I'm just going to color them blue so you know which ones are somethings and which ones are not somethings. Wait. So
I
it's
love
marked
this
something. Okay, and y equals
So
a
it's
cosine.
2
What?
plus 2 is the last one.
Okay.
We know it's a cosine, and
I sure it's plus 2.
yeah, because 2 is the line that it goes through that it repeats on.
Oh yeah, I just saw that. Yeah, that's like a midpoint. Yeah.
Is this stretched at all, or is it already said stretched?
It doesn't look like it. Not that I could see.
It does. It goes to the right 3 pi over 2.
3 pi over 2. Turn that back to black.
I don't think we need anything there.
2 pi over b. We do in fact. Maybe not though. What is a again?
So a is what's it called? So
The stretching and shrinking, and I don't think we need that.
no, we do.
Oh, we do.
Yeah, we do. I want to say that we put want to say that we put a 3 there.
Yeah, no. Because normally cosine has a period of 2 pi. And it's now having a period of way more than 2 pi.
Well, okay, so my bad. Then we do need to put something where you said we don't, where I said we don't. So that's highlighted right now, the green.
Mm-hmm.
Determine like the length of the wave or the length of the whatever that goes after cosine.
Yeah.
So what's highlighted in green is supposed to be 3.
That's supposed to be 3. Oops. Uh-huh.
And can you see why?
I think this is actually an inverse of cosine, the graph, isn't it?
Yeah, because it's going through the origin.
So we've got to have a negative number, right?
Well, is it going through the origin, or can we just shift it? Because it doesn't look like it's going through the origin exactly.
Oh, yeah, you're right.
Like, it looks like they just moved it to the right a little bit.
Wow, that got small. I didn't know that's possible.
That picture looks really good zoomed out. I don't think it's
a -3 though. I really don't. I think this is the same graph. I just think this isn't a regular cosine. I think it goes through 0, and I think that's what they're attempting to do on that.
Well, a regular cosine starts at 1, doesn't it?
Yeah.
Well, yeah, but this is flipped inversely, so I guess if we moved.
Why is it flipped inversely?
Because a regular cosine starts at 1, 0, and then goes down, moving from right to left, and it goes down to about -1, and then back up to 1.
So it starts at down or it starts at 1 and then goes down, right?
Yeah, so it starts top 1, so at 1, 0, and then it goes down to
-1,
-1, something along those, and then it goes back up to like 3, 1.
But then couldn't it just be stretched like long ways and then just move to the right? Because if you move it 3 pi over 2 is what we have in the parentheses, that would make it a regular cosine just stretched.
It just looks inverse to me, but
like this is it's hard to tell, because are we supposed to start at the bottom? Because then we would move it to the left. Or are we supposed to start at the next peak? Like, I feel like at some point you could use several different equations to get like the same graph, because all you're doing is moving something that does that right and to the left, and you get the same thing on either side.
It is inverse, because I just remembered. So if you look at a cosine normally, it should look like a V, like a cursive V. But now you see that it's an upside down cursive V. So it is flipped. It is flipped.
I think so. What I think it is, I think it's flipped, and then it's moved up 1. Because what's the peak hitting up there? I can't see the number on my screen.
5.
The peak's hitting 5.
Yeah.
Jeez. I'm pretty sure a regular cosine only hits a -1. So
Yeah.
That's why we have to stretch it
up to a 5.
So it's supposed to be, the number 3 is supposed to be there, but whether it's inverse or not has nothing to do with the 3 that's supposed to be there. So it could be -3 cosine.
Question is, what is B supposed to be? Well, I know the period itself, to get the period of any graph, it's 2 pi over B. So we could solve that algebraically. But do we know the period in the first place?
I just missed a call. Hold on, guys. I'm gonna put my thing on mute. I think it's an important phone call, but I don't know because I don't have the number saved. So I'm gonna be right back.
All right.
So let's see here. Well, the number in front of the x increases the frequency, right, of how fast it goes, I believe.
Let's see what we did before here. So it stretches the amplitude out. So we were
Yes,
saying
that'd be
before.
the stretch.
Yeah.
I wonder what makes it go. We got to get it stretched up somehow, I think.
Yeah.
Okay, so 3 is a stretch, right? So wouldn't it be -5 cosine because we're going up to 5? That would stretch the frequency up to 5. I think it'd be -3.
But we're not
I
starting.
think it'd be -5 cosine and then -1 for the frequency.
Perhaps, but the only problem
And
with
then
that
I
is
think it's just x minus pi because a 3/2 pi would increase a 3 pi.
the only problem with this is
A 3 pi over 2 would shrink it. It would make it come closer. So I don't think that's 3 pi over 2. I think it's just pi.
the other problem with this -5 is that we don't start at 0. We start at -1.
You know, I don't think it would. I don't think it would.
Let me just check it. Check it with a graphic calculator to make sure this dealio works.
Because I know that the 5 would stretch it up to 5, which would get us that, and that would probably pull that bar over from not touching the origin.
Mm-hmm.
But I don't know if that would make it too steep or not. But I don't know. That's my best guess at it. I know that -5's got to be there because that's the only way you could get it to stretch up to 5.
That's correct. That's correct. Just think.
What's that peak? What is it? 3 pi over 2. It's 3 pi over 2 5. Where
What?
that point ends? Right there at the peak up there.
This one?
Yeah.
Yeah, 3 pi over 2 right there.
So it's what, 3 pi over 2 5? How would you get that?
Maybe that's why he was trying to put that. I could try it out.
Well, if we look at our previous questions, right?
Yeah.
That wouldn't help. I don't know.
No, that doesn't make much
So
of a
there's got
difference.
to be something in front of the x, right?
Yeah.
Maybe.
Oops.
Maybe we just need to move it over one.
It's only going down 1. No.
Minus pi. How do we get it to stretch out farther? I can't remember.
I don't know.
This is a pretty wide stretched graph, right? And 5 just moves it out, so we need to
Yeah.
lower the frequency. It's not so peak, but I don't remember how to do that.
You could write, that's the key, right, Dallas?
Would it be a fraction? Would a fraction shrink it?
I think so.
Stretch it?
Where would you put the fraction, though? At the -1?
I'm thinking we've got to put something in front of the x, because in the other ones, if we look at the practice key,
Uh-huh.
the extension problems practice key, what they do is they have 2x minus pi, and then it says they moved it right pi over 2, which is kind of an interesting thing. I was just looking at the practice problem.
Yeah.
And so I'm not sure how to stretch it out.
Yeah, that looks like it's working.
I think we've got the general idea, but it just needs to be widened.
By a fourth, maybe? Maybe. I don't know.
Well, actually, you're onto something, because 1 over 4, or I did 1/3 and it stretched it out. I'm using a little graphing thing. Maybe we don't need a negative here. Maybe we don't move it over that far. Maybe not. What? No, but that clear over at 10. So if we do, move this right. Well, no, that's too far now. It's going to be 3. Maybe there's a 1/2 in front.
1/2?
Well, in where that -1 is,
Oh, maybe.
I'm wondering if that's where the fraction would go.
Definitely not. Maybe, actually.
Maybe our fraction goes outside of that x.
Maybe something onto something. Hey. That might have just been what we needed right there. Yeah, that was it. That was it. Move it over. Yeah, that was it.
Whoa.
Whoa, 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 whoa. That was complicated.
So you did -1/2 on that one, and it worked out. It worked out.
It looks like it was working out. You'd have to check yourself, though. That is. Oh, wait.
No. I'll show you what I'm looking at.
I mean, it's close. I don't think it's perfect, but it's close.
Well, here's what I got when I put that in. It's way too wide.
Oh. That is true. It is way too wide.
But if we manipulate this one, -1, put it there, but it's still too wide. That looks good, actually, because that's 5. That's 3.
But it only goes down -1.
Oh, this bottom part only goes down to 1?
Yep. Yep.
Really? How in the heck? How do you get one side to go up to 5 and the top only go down to... Maybe it's not inversed then.
Perhaps he knew something that we didn't know.
Well, maybe there's not one... I don't know how to get one side up to 5. I wonder if there's a sine and a cosine.
I don't think so, because that's not in the format that she gave us to do. Oh my gosh.
Another 50%. Here we come.
I hope not. Oh man.
I wonder if there's a way to put cosine here with point. I don't know though. It's not gonna work. I have no idea. I don't know.
Oh gosh. Oh man.
So what are some points on that graph that we're looking at here?
You know, that might be not be a bad idea.
So if we did,
Because you could use
if we graph the
decimals.
points, then we might be able to at least see what's happening.
Do we have any solid point? We have
Well, you got 5 and 3 pi over 2, and then there's also -1, negative pi over 2, -1. And then there's also 2 pi and a half. Does that make sense?
Hmm.
Can you yeah. If we do negative pi over 2. Bless you.
Thank you. Not to go blow my nose, of course.
1.
What?
2.
Hmm. wonder.
So, well, I don't know how this would work though. So, hang on.
I know those TI graphing calculators. I think they let you graph graphs by points. Not sure. So we'd have to wait on that.
Hmm.
It looks like she used Desmos actually. She used Desmos to do it. Mm-hmm.
I got a video if we want to watch it. That might help us out to figure it out.
Perhaps.
All right, are we still doing this?
Yeah, we're watching a video on Jason's screen.
Oh, sorry.
You good?
Oh, this is a lot simpler than the equation we have.
Of course it is. Hmm.
Well, does that help anybody?
I mean, the problem is I don't know what is the defined period for this graph. So I understand what you're saying about 2 pi over b. So if it's cut off right here at pi halves and goes to 7 pi halves, that could tell you a period, but I don't know what exactly the period is supposed to be defined as.
Well, basically with his, we could find A and B, but how do we figure out C and D?
Who knows?
Are we on the quiz right now, or
Yeah,
still?
this is the straight up quiz.
We're on the quiz, but we just have absolutely no idea what the heck to do for it.
So do we have to write the equation?
Yeah, we're
Yes.
still trying to find the equation, and we found one that was similar, but our graph kept going down to -5 and +5, so we don't know how to make the bottom of the graph stop at -1. Unless it's moved up.
Can you move, I guess, zoom out a little bit so I can see the equation you guys have?
What if it's not -5
Or
and
positive
it's
5?
some other thing, and then all it's done is that the graph has moved up? That would get us to the -1.
Sorry, the A isn't 5, A is 3.
Okay, we'll start with that.
It could be -3. I mean, it could still be, but the number is 3. And because the line that cuts through the whole thing is 2, and 3 above 2 is 5, and 3 below 2 is -1. Does that make sense? And then, so we've got those right. And then okay.
So, fix screen share. So using this equation that we have right now, we get a graph that looks like this, which actually gets us to the 5 and the -1.
But it's just not
We
stretched
just
properly.
have to shrink it though, so it's not so wide. Might be taking this out.
Maybe.
So let's shrunk it a little bit, and then if we take this out, we'll see what happens. It's not 3 pi. But at least it's at 5 and -1. Looks like it needs to move left 1, maybe?
Perhaps.
How do we get the graph to slide left 1?
You have to go wherever's inside the parentheses, move left or right.
This one?
Yeah, so it'd be 1.
So it'd be -1x. That didn't do anything. What if we did a plus pi?
So a normal cosine graph goes from 0 to pi, or it goes 0 to 2 pi.
0 to 2 pi, I believe. Or
so what if we just shifted, yeah, like you said, one little 1/2 pi to the left? That way it would be, we would have, because right now it's just, let's see, if we should, it would be 3 pi to -1 pi. So it'd be 4 pi. So wouldn't it just be 2? So cosine, okay.
That's getting closer with what I've got on my screen. If you look at it, it's getting, this is hitting about, not quite at 3. But we've got the -1. It's almost crossing over there. Oh, that's pi over 2, right? And so what's that point? Is it 3 pi? What's this top point in the actual graph?
which point are you pointing to?
The top, the peak. The one that's something, something 5.
Pi halves over 5.
It's pi half?
Pi halves, yes.
Pi halves.
Which would be right here.
No, what's this point though, right here?
This point way up here is 3 pi halves, 5.
So we just need to get a
Hey, try this.
because this is pi halves, so we just need to get 3 in there somewhere, and then we got it, right?
Jason, can you try an equation for me? Type it in up there.
Yeah.
So can you put -3 cosine and then in parentheses 2x plus 3 pi halves?
Oops.
Parentheses plus 2.
So just copy this.
That's a little bit closer.
Yeah, it's the wrong way though, and that's pi over 4. What's this one though? It's 3 pi over 4.
How did we get it?
Because this is multiplying out. These are multiplying out. So I wonder if it's just 3 pi. Then that gets us to what? Pi 5? 2 pi 5. 3 pi 5.
This is
So maybe this one's 1/2 then, maybe?
No. We had out closer before.
like of the graph that we're supposed to do it. The y-intercept is like skimming 0.
Oh, that's all right. I might have that. So what was the other one that we had? So we had this one, which was at pi halves over 5, which is close. We just got to get that to 3 pi halves, right?
Yes.
This one's close. We just got to get that point to 3 pi halves. Which has to do something in here. This is the number we're missing. We got to get this to either this one or this one at the 3. Oh, wait, maybe, did we try 3 here? That didn't change anything.
Nope.
Why didn't that change anything?
Nobody knows.
That's weird. This is multiplying to 2x. And then it's also multiplying to 6 pi. But it wasn't like interactive where I could move it.
That'd be awesome.
Hey, 3 pi halves over 5.
But now you're going down 2. Not down 1.
No, -2 is there. This is still -1. It's 0, -1.
And I think you might have to adjust the left and right because if you look at the graph originally, or maybe not. No, yeah. I think you're good. I think you got it.
Well, what's this point here, though? There's not a 0, -1 point on your graph, right?
No, there isn't. So I just have to be moved left to right.
So it needs to be a little wider. So it'll come out like this. You know?
Yeah, I think so.
So it's got to be with this then.
Okay. No.
Sorry, I was watching a video of how to do this, a different video. So our leading coefficient, A, is plus or minus 3. We've got that. We've got the 2 right. and our B is 1/2. Because the distance from peak to peak is 4 pi.
This is 1/2?
Our B is 1/2.
Yeah, so that, yes.
So then we just have to move it over a little bit, don't we?
It looks like it.
Because we have the right amplitude and the right period. We just have to move the graph over.
Which would be this number?
That's up and down.
It would be inside the parentheses.
So something has to be
Maybe
added to
this is
3
a
pi.
minus?
That looks a little bit more accurate.
No, it's too wide though, isn't it?
No.
Yeah, try 3 pi over 2. I don't know. That's just a guess. Nope, that's not it.
Nope.
I'm gonna go on mute for another 2 seconds and
What was this one? 3/2? Oh, it's 2/3. Maybe just because that was a plus. That gets us our 3 pi over 5.
Hmm.
Maybe it's this number. What does this do?
No, we don't want to add there.
Holy crap. Maybe if we make
why did we change the B to?
I was just looking at it.
Oh, okay.
Yeah.
Well, can I explain to you why our B is 1/2?
Sure. Shoot.
Would that help? I don't want to like cause more stress and contention.
There's no stress or contention. I'm just messing around with the formula.
So on the actual quiz, it has the 2 minimum peaks going from 7/2 over 2 to -1/2 over 2, or negative pi halves. So 7 pi halves to negative pi half. If we were to shift it one section to the left, it would be 3 pi and then -1 pi. And so that gives us a period of 4 pi. And our period helps us find B because B is equal to our period, or I guess 2 pi over B is equal to our period. And so you have 2 pi over B equals 4 pi. That means B would have to be 1/2.
Well, no, because wouldn't you divide the 4 by 2, which would just equal 2 pi?
What?
Because you said it's 4 pi and then 2 pi, right? Or whatever that formula was.
No,
that
because you have to multiply both sides by B, and then you'd have 2 equals 4B.
Oh, okay. So this moves it right 3 pi. I'm just going to test some stuff. We'll see. 5, 6.
Oh.
What? Should we move on and try and do some other problems?
That's what I'm doing right now. Taking a break. My head is hurting way too much.
I feel like if we've got half of the equation right, at least we won't get a complete zero on it, maybe. I don't know.
Why don't we do that? Let's focus on some different problems. And sometimes that happens when you're just too focused on something. It just won't come to you. It'll come to you when you're trying to focus on something else. So let's take a break from that problem for a while and move on to number 2. Then we'll come back to it.
Fine by me. Didn't we do an assignment that was like this problem?
Mm-hmm. Mm-hmm.
So, if I remember correctly. So we use that formula.
Mm-hmm.
And then you square it because it's cosine squared. So you'd square 25. And then you'd plug that into sine squared x plus the 25 to get rid of the cosine. So it'd be 25 squared. Since we already know cosine.
Sine squared x plus.
So it'd be a 625 equals 1. And then you just subtract it, I believe, from that. And then you take the square root of the number to get rid of the square root of the sign.
Yeah.
Sine x equals the square root of 624. And then I don't know if we're supposed to factor that out or if we're supposed to solve it, but I got 24.97999.
$24.999.
97,999. So I guess 98 would probably suffice.
0.798.
0.98 equals sine x. So I never know if I'm supposed to solve it or if we're just supposed to factor it out. If we factor 624, that would give us a different answer, wouldn't it? I don't know how you would factor that.
Can't even think anymore.
No, that's how you do it. It just depends on if we factor the square root or not. Which I'm assuming they'll probably accept both, I would hope.
I should hope. All that good. And then use the fundamental identity to write two functions for cosine alpha in the items of sine alpha. And take which formula to use for the given value of alpha. What?
Fundamental identity. Right, two functions for cosine alpha in terms of sine alpha. So that's kind of what we're supposed to, I think that's what we did up above with the sine squared x plus, what would be sine squared alpha plus cosine alpha squared alpha equals 1. Isn't that one of them?
I presume. Now I have to know how to do the shortcut for alpha. Oh boy. Give me a minute. Alpha. I wonder if it is. Nope. Nope. No. Well, that's annoying as crap.
Is this just the opposite type thing, like the ratios? Is that all we got to do?
We'll just say that's the alpha. I'll just do alpha.
They're co-functions of each other.
Plus cosine squared alpha equals to 1. Actually, no, I might be able to change that. There's beta. Where is alpha? I guess we're just going to use that for alpha.
I really wish our teacher would do kind of like a teaching lesson, one of these. Instead of having two group meetings, I wish she'd have like one where she actually taught us how to do stuff.
Oh, if only.
The problem is if your entire group doesn't know how to do it, you're all kind of stuck, you know?
Yeah, you can't just like ask the teacher.
Yeah.
Oh, what an idiot. You know what an idiot I'm being right now? I just copied it from the question. Duh. Ding. That would have saved a lot of time.
There you go.
Okay. So is that 1? So there are two functions for the cosine of alpha. Oh. I think she wants us to have it so it equals the sine of alpha. There's a way to do that, but I can't remember how to do it. Two functions for cosine f and items of sine indicated.
Guys, I think I solved the graphing problem.
What was it?
I think, are you ready for this? You guys might want to type it in on your own graphing calculator, but I think this is right. I think it's negative, let me go back to my graph, -3 cosine, parentheses, half x plus pi over 4.
Plus pi over 4.
And then plus 2.
And plus 2?
Yeah.
Looks like it worked on mine.
I'll trust you guys. Let's get these transformations in there.
Oh, that was so annoying.
How did you figure that out?
So, I went on to like a similar thing that you were at, like the online graphing thing, and I typed in, like, I knew that our transformation was supposed to be 1/2, like x half, and I knew that it was supposed to be -3 cosine and then plus 2, and then I knew that it was supposed to be a fraction in the pi, so like I was close when it was 3 pi over 2. But we were off when we were doing the minus, and it was supposed to be plus. And then I just kept on increasing the graph for pi. So pi over 2, pi over 3, pi over 4, and pi over 4 was the answer.
Well done.
That was something I never want to do again.
So what were these transformations?
I'm sure it'll be there.
I don't know.
I'll have to start like a day before just so I can finish on time.
So you can plug and check for an entire 24 hours to see which one comes closest.
It's stretched by 3, reflected over the x-axis. I want to know how many other groups like either figured or didn't figure out how to do this.
I always like to look at the statistics when it comes out with the quiz, just to see what everybody gets.
Sometimes
every quiz, there's 5 people who get zeros on it. So I wonder if there's just a group who literally is just not doing it.
Probably. Which is kind of dumb because this class is freaking expensive. 5 credit class.
Yeah, it is. It's crazy.
Anyway, I think.
What's the period for this? Isn't that one of the transformations?
The period is 4 pi.
Would it be 4 pi or pi over 4?
No, the period is 4 pi.
Yeah. Because it's the distance between the whole thing.
Yeah. So that'd be one of the transformations then, right? 4 pi?
Why not?
I want to get credit for this question. We put everything that she could possibly want.
So.
Then what's the last one?
The
stretched, reflected.
Well, so the period. Okay, so the period is 4 pi, yes, but b is 1/2.
B is 1/2. So how do you put that in terms of transformations?
We 1/2 the b. I don't know.
We 1/2 the b. So for her transformations that she put, it's got the period, the reflection, shrunk, the right, and the up.
Okay, so the period does stand for the.
Yeah.
Shrunk by 1/2, I guess.
Yeah.
Well, no, don't put period is 4 pi because that's the correct thing.
Well, yeah, but she's got on hers on the answer key for the Previous one, she has both the period and the shrink. You know what I mean? That's the only thing we're missing. Well, we have stretched by 3. Never mind. Oh, so we're missing the shift to the right or the left.
Wouldn't it be to the left by pi force?
Yeah.
Yay. That was insanity.
Yeah, sucks.
Hopefully I can get to this one without the fun one. To write 2 functions for cosine of alpha in items of sine alpha.
Did I tell you guys I've never been good at trig?
I have like a hard time with moving past things. Like I hold on to grudges. So like if a problem is like so frustrating that we decide that we need to move on, like I at that point I muted my mic and I like dedicated my life to that problem.
Okay.
Here, I found this thing, if this would help us, since we don't really seem to be. Oh, I sure didn't. Here's a bunch of additional. Oh, dang it! Additional formulas that have all the sine, cosine, and stuff. I don't know if this helps.
Let me see. Let me see.
I guess that's sum of angles, so I don't know.
Oops.
I don't know if any of these are official.
Oh, frick.
Anybody looking at these or not really?
I like don't know what I'm looking at. Like that's my problem.
Yeah, me neither.
That makes sense to me. This one, because this was talking about when you have the sine of a really big angle, you can divide it up into 2, alpha and beta. So that makes sense to me. Same with tangent. And you can also take 2 smaller angles and that you don't know and add them to be an angle that you do know. That makes sense to me. And they're talking about imaginary numbers. But there's got to be, oh yeah, this is talking about when you have tangent, you can split it up into cosine and tangent and then find it that way. But I know you can write this formula, the fundamental identity formula, in terms of cosine. It's such a pain in the butt. I remember doing it last semester. Such a pain in the butt. Fundamental identity formula in terms of cosine.
Okay. Somebody using that.
do. Do. Oh my gosh. So do you guys get what I'm trying to do here?
Yes.
So I take this formula and write it in terms of that. And all these things over here has to be in terms of sine. My professor put this on the final. It killed me. Totally killed me.
You're what?
My professor last semester put this exact problem on the final. It was killing me. Just killing me, man.
If you don't mind me asking, what did you end up getting in the class?
I totally failed it.
Like the class?
Uh-huh. Well, it's not only that, just the professor didn't like me in general, so, you know, that's what
How could he not like you, Chris?
that's what I think, but honestly, he's a total jerk.
I'm trying to get it.
Oh my gosh. Yeah,
Whoa.
it's being all trippy.
Everyone's freaking out now.
You trying to get an internship in Melaleuca?
Yeah.
We had Krispy Kreme donut. Jelly beans that broke $2. They had Cold Stone jelly beans, all of them.
Oh, nice.
So, well, the screen share function on my computer just is not working. So that's perfect. It won't even show me either. That's just perfect.
Well, whatever you put, I trust you, because I have absolutely no idea.
Oh, there we go. Okay. There you go. There we go. It's all back together.
We're just trying to find the equivalent, two trigonometric, like equivalent
Yeah.
things.
So we're just writing this equation in terms of cosine of alpha.
I honestly have no idea how to do that.
So that would be sine, and would that one be? Oh, is that the sine? Isn't there a thing sine parentheses alpha plus pi over 2?
Oh, alpha plus pi over 2.
Yeah, because I use that a lot in the homework.
I don't remember.
It just looks like the one you're trying to solve right now. That's probably what I'd put. I remember doing it in the homework.
Plus pi over 2. That doesn't look right to me. Let me try again to look it up.
I looked up the formula that I just told you, and here's what I found on it for the two formulas. This one right here.
Oh. Well, that answers that. Thank you.
I don't know, is this one for tangent or is this one for cosine? I know this one we used.
Yeah, we're just trying to do this one. I don't know why there's supposed to be two functions though. Maybe there was. Oh, bring that thing up again.
Bring this one up again?
Maybe that's the other one she's talking about.
Yeah, I'd probably do the Pythagorean theorem one and then
Oh,
this one.
wait. Hold it right there. Because you can do this with that website that you're on right now. You can also do sine of alpha times tan of alpha.
Oh, this one?
Yeah. Sine of alpha times cosine of alpha times tangent of alpha. I think does that make sense to everybody? I mean, that looks pretty solid to me.
I mean, I trust you. Like, there's a lot of trust happening right now.
I mean, if we get another 50, whatever.
Half the grade is the participation from Tuesday, so we already got that 100 down.
No.
I don't know. This is a tough quiz for me.
It's killer. It's all killer, man.
We don't have an exam this week, do we? Just an individual quiz.
No, thank goodness.
Yeah, but those individual quizzes are also killers. Especially if there's going to be questions like this.
I forgot those. Oh, man. Oh well. Okay. And I'm thinking we're going to use the first one. She's supposed to indicate. We will use the formula.
Indicate which formula to use for a given value of A.
Of alpha.
Or, yeah, that's what I mean. Couldn't you use any of them?
I guess, but I think this one would be simpler.
Yeah. Oh, and just because I think they're a little picky, you've got a parentheses after pi on the first one instead of the parentheses after the two.
Say what?
Right where your mouse is. So this is what right here, this is the one I'm talking about on my screen.
Oh.
Yeah, it's pi over 2 parentheses instead of pi parentheses over 2.
A plus option. Pi over 2.
And then closing parentheses at the very end of that. Yeah. Just in case they're a little picky.
Yeah. Sure.
And I think that does change it because then you're doing alpha plus pi, and then you're dividing that all by 2. So.
I think that should be good. Oh man, that was painful.
Well, we gave it our best shot if all else fails.
We gave it a college try is what we did.
We gave a bunch of guesses and tries and are praying that it works.
Hey,
We're making cool DNA strands, so
I was gonna say we made a really nice looking DNA strand.
No kidding.
I mean, it looks good. I'm like, I might print out the equation to the graph that took us hours and put it on my wall.
Just because
I might put it on my resume.
I finished this problem.
Okay. So I think we're done here, if I'm not mistaken.
I would agree wholeheartedly.
I'm done. I am done for the day.
Okay.
I was going to try and finish my last 2 math assignments today, but I think those are on now.
They are?
I have no determination to try and do them now.
Yeah, I'm going to go take a shower.
All right, have fun.
Thanks.
Okay. Well, I guess I will See y'all next week.
All right, I'll see you guys next week.
Alrighty. See
We'll
ya.
see ya.
See ya.